Hello everyone, this is Vasanth, the ninepointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a problem on shear stress. So this is the problem. There is a beam which is made by using two boards and they are connected by using a glue, right? So we need to find out the maximum shear stress in glue necessary to hold boards together. See, we already discussed in the lecture when it is under vertical loading, then these two boards will try to shear off, right? So this glue will resist them. So to resist this glue, so we need to first find out the maximum shear stress in this line, right? So that maximum shear stress should be resisted by this glue to hold these boards together, right? So for this loading, it is clearly visible that V will vary, shear force will vary, and we need to find out the maximum shear stress in the plane containing the glue. So this is the plane containing the glue. We know the shear formula, that is tau is equals to VQ by IT. So tau max for this see, I is fixed, T is fixed and Q is fixed. So the only variation will be in V. So we should choose that section where the V is maximum for tau maximum. So this should be maximum. So first we need to find out the maximum shear force. See, for a given loading, generally the maximum shear force will occur where V dV by dx is equals to W, right? So for maximum shear force, this should be is equals to 0. So W is equals to 0 for maximum or minimum shear force. So that can occur in this region or at this support right? So at the two ends of the supports and in this region, right? So let us find out the reactive force first. So we can take this as F, and this is some force, and we can say this net load will be 6.5 into 4, right? So that will be 26 kilonewton, right? So if we take that, we can assume as acting over here 26 kilonewton, and this distance is 2, and this distance is 2, and this distance is 4. So we can apply moment equilibrium over here. So that will give F into 8 will be is equals to 26 into 2, right? So F will be is equals to 13 by 2. So 6.5 kilonewton. So this will be 6.5 kilonewton. Then this will be 26 minus 6.5. That will be 19.5 kilonewton, right? So if we draw the shear force diagram, see initially it is 6.5. So if we cut over here, the shear force over here will be 6.5. That is positive. Up to this 4, right? So after this, see here the shear force will be, so this is 19.5. So here the shear force will be negative minus 19.5, right? So from here to here it will vary. So somewhere in between it will be 0, which will go to here, right? So the maximum shear stress you can clearly see V max in magnitude we need to consider. So that will be 19.5 kilonewton. Okay. So we need to take V max, that is equals to 19.5 kilonewtons. Now the remaining is we need to calculate Q, I and T, right? So the T should be this one, the plane containing glue is this T, not this T, okay? That you need to understand. So this T is 30 mm, right? And we need to calculate Q. So for Q, we need to consider this area, right? So this area will be, for Q, that area will be 150 into 30 and into Y dash, right? So see, you can calculate this neutral axis position, means that is centroid position. So this will be 120 mm, that you can calculate. Actually this question that was given, okay? Y dash is given, that is 120 mm, okay? So this distance, इसका centroid का distance will become, see, this will be 30 mm and this distance will be 15, so that will be 45. So 150 into 30 into, let us write this y dash dash, so into 45, okay, mm cube. This is cube, and we know the value of V, that is 19.5 into 10 cube Newton, and we know the value of T, that is 30 mm. And what is the value of I? So for I, we need to calculate the I of this section, right? This whole section of this I beam, right? So, and this is, we need to calculate about neutral axis. This is at distance 120 mm, and this is at distance 30 mm, and this distance is also 30 mm. So we know that I will be, see, we can calculate in two parts. See, first let us take, we know the I about, if this is a rectangular beam of height h, and if it is centroid of the rectangular beam, for that I will be dh cube, means th cube divided by 12. But for this is 170. See, this is, sorry, 150 meters, 150 mm. So the centroid will be at 75, right? But it is at 120. So that means because of this 1 and this is 2. So because of the 1, that will be th cube by 12. That means this is 30 and this is 150 whole cube. Okay. Plus area is t into h, means t into h into d square, that will be 120 minus 75, right? So that will be 45, right? So 45 square divided by 12. So this will be 30, this will be 150. So this is for section 1, and we need to calculate for section 2 as well. So for section 2, for about centroid, suppose this is 30, right? So this is given as 150. So we can write about centroid IC will be this 30 whole square whole cube into this 150 divided by 12. But we need to calculate about neutral axis. So this will be 150 into 30 whole cube divided by 12 plus area, that is 150 into 30, right? So into d square, that d, see, this will be at, this is the centroid, right? So this will be at, this is 15 and this is 30, that means 45 whole square. Sorry, here there will be no 12. Okay. So this will be 2. So this will give I of the T section, that will, we will get as 127, sorry, 27 into 10 power minus 6 meter power 4. So that can be converted as 27 into 10 power minus 6 into 10 power 12 mm power 4, right? So tau max required in the glue should be equals to 19.5 into 10 cube Newton into Q. Q is given by 150 into 30 into 45 mm cube. This is Newton divided by 27 into 10 power 6 mm power 4 into T is 30, right? Is it 30? Yes. So 30 mm. So it will be value into Newton per mm square. So this will be megapascals, right? So if we calculate this value, we get tau max required in the glue is 4.88 megapascals. So minimum this much value it should be able to resist to hold these two boards together. Okay. I hope you understood this problem. If you like this lecture, do subscribe to our channel 9pointer. Thank you.